Hello, everyone. Today we will explore the basic relationship of trigonometric functions with the same angle. Last time we learned a new function, trigonometric function. Please recall, how do we define it? We put the angle alpha in the plane Cartesian coordinate system. The vertex of the angle alpha coincides with the origin O of the plane Cartesian coordinate system, so that the edge coincides with the non-negative half-axis of the x-axis. The final edge and the unit circle intersect at point P, and the coordinates are x and y. We define sine function as y equals sine alpha and cosine function as x equals cosine alpha. The tangent is y to x equals tangent alpha. Here, the sine function is a function with the angle alpha as the independent variable and the ordinate of the intersection with the unit circle as the function value. Cosine function is a function with angle alpha as the independent variable and the abscissa x of the intersection with the unit circle as the function value. The tangent function is a function with angle alpha as the independent variable and the ratio of y to x as the function value. According to the definition and the quadrant where point P is located, the sine law of the function value can be determined. For example, when point P is at the second image limit, what is the sine of the trigonometric function value? Because point P is in the second quadrant, x is less than 0, cosine equals alpha is less than 0, y is greater than 0, and sine alpha is greater than 0. The y symbol is different from the x symbol, so tangent alpha is less than O. In the previous study, we extended the angle from 0 to 2 pi to any angle. There are large positive angles, and we are not familiar with the negative angle. How to study? Can we connect them with familiar angles and replace unfamiliar ones with familiar ones? For example, if the terminal edge of the angle alpha is determined, its coordinates with the focal point of the unit circle are uniquely determined. What are the rules of the trigonometric function values of the angles with the same final edges? The answer is equal, because the coordinates of the intersection point are uniquely determined when the terminal edge of the angle is determined. So a definition, the same trigonometric function value is equal. Can you use symbolic language to express that the same trigonometric function value of the same angle with the same end edge is equal? I believe you will be able to write it soon. Sine alpha plus 2 pi of k times equals sine alpha, cosine alpha plus 2 pi of k times equals cosine alpha, tangent alpha plus 2 pi of k times equals tangent alpha, where k belongs to z. We call this formula Formula 1. In the later study, we will also study Formula 2 to Formula 6. Formula 1 reflects the law of cyclic change of trigonometric functions. That is, the function value will repeat every time the terminal edge of the angle alpha rotates around the origin. This is the characteristic reaction of the point on the unit circle rotating around the circumference for an integer circle and still returning to its original position. Well, let's try to solve a problem. Find the value of the following trigonometric function. First, sine 25 pi of 4. We can use the definition of trigonometric function to solve it, but 25 pi of 4 is a big positive angle, which is not easy to draw quickly. Now we learn Formula 1. Can we find the same angle as the terminal edge of angle 25 pi of 4? And this angle is our familiar angle within 0 to 2 pi. We can subtract an integer multiple of 2 pi from the base of 25 pi of 4. For example, 25 pi of 4 minus 3 to pi is equal to 4 of pi, and 25 pi of 4 is equal to 4 of pi plus 6 of pi. At this time, 25 pi of 4 and quarter pi are the same angle as the terminal edge, and its sine value is equal. Sine 25 pi of 4 is equal to 1/4 of sine pi. What is the sine of a particular angle? 2/3 root sine 2. Second topic, cosine 8 pi of 3. We look for the same angle as the terminal edge of 8 pi of 3, and this angle is in the familiar 0 to 2 pi. Then subtract the integer multiple of 2 pi from the base of 8 pi of 3. For example, 2 pi can be subtracted from 8 pi of 3 to equal 2 pi in 3. 8 pi of 3 can be expressed as 2 pi of 3 plus 2 pi, then its cosine value is equal, and cosine 8 pi of 3 is equal to 2 pi of 3 of cosine. Let's consider that 2 pi is the second quadrant angle. Is its cosine value positive or negative? I believe many students answered correctly, which is equal to -half. The third question, he knows the negative 11 pi of 6. Negative 11 pi is an unfamiliar negative angle. Can you find the same angle as its final edge? And this angle is the familiar angle between 0 and 2 pi. We can add an integer multiple of 2 pi to the negative 11 pi of 6. For example, negative 11 pi plus 2 pi is equal to 6 pi. Negative 11 pi is equal to 6 pi minus 2 pi. What does this formula mean? The negative 11 pi of 6 is obtained by rotating clockwise on the basis of the 6th pi, which indicates that the negative 11 pi of 6 and the 6th pi are at the same angle as the final edge. Their tangent values are equal. The negative 11 pi of tangent is equal to the 6 pi of tangent, which is equal to the 3 root sine 3. Through the answers to the above 3 questions, what effect do you think Formula 1 has? It can convert the trigonometric function value of any angle into the trigonometric function value of the range angle from 0 to 2 pi. Okay, we have studied that the same trigonometric function value of the same angle of the terminal edge is equal. So let's think about whether there is some relationship between different trigonometric function values of the same angle at the end edge. First of all, we know that the values of the 3 trigonometric functions are uniquely determined by the coordinates of the intersection of the terminal edge of the angle and the unit circle. This shows that the background of their definitions is unified, so there must be an internal connection between them. Secondly, there are countless corners of the terminal structure. How to study them? We can use Formula 1 to convert the trigonometric function value of these angles with the same end edge into the trigonometric function value of the same angle. At this time, this problem can be further transformed into the study of the relationship between the values of 3 trigonometric functions of the same angle. Now let's discuss it together. Let me give you an angle alpha. Let's set the end edge of the angle alpha to rotate to the second quadrant. Can you find a line segment corresponding to the p-coordinate in the unit circle? Thus, the relationship between sine alpha and cosine alpha is established. I believe you can see that we make a vertical line of x-axis through point P and intersect x-axis with point M. At this time, the absolute value of x is equal to the length of line segment OM, and the absolute value of y is equal to the length of line segment PM, and because the triangle OMP is a right triangle, and up is equal to 1, then because of Pythagorean theorem, the square of OM plus the square of MP is equal to 1. So, x squared plus y squared equals 1. According to the definition, the square of sine alpha plus the square of cosine alpha equals 1. Can you rigorously prove this conclusion? Does the triangle PMO exist when the angle alpha is any angle? Obviously not. The triangle PMO exists only when the angle alpha is a quadrant angle. So we want to prove this conclusion. First, we need to discuss diagonally. When the angle alpha is a quadrant angle, there is the following proof process. We can conclude that the square of sine alpha plus the square of cosine alpha is 1. Is this conclusion still true when the final edge of the angle alpha coincides with the coordinate axis? For example, when the terminal edge of the angle alpha coincides with the non-positive half-axis of the y-axis, its intersection with the unit circle is 0 and -1. At this time, there is still x plus y equal to 1, so the conclusion is true. Moreover, no matter which coordinate axis coincides with the terminal edge of the angle alpha, there is always x plus y equal to 1, so the conclusion is also valid. To sum up, alpha is any hour, and we all have the square of sin alpha plus the square of cosine alpha equal to 1. This is the first basic relation of trigonometric functions with the same angle that we have learned. Okay, let's think about the relationship between the trigonometric function value of the same angle. According to the definition, tangent alpha is equal to y over x. It is equal to sine alpha over cosine alpha. And does the formula hold when alpha is any angle? If we want the formula to hold, we must make the function meaningful. Cosine alpha on the left of the equal sign as the denominator cannot be equal to 0, that is, x cannot be equal to 0. At this time, the terminal edge of the angle alpha cannot coincide with the y-axis, and alpha cannot be equal to half of pi plus p. The definition of tangent alpha on the right side of the equal sign. Alpha cannot be equal to half of pi. So in this formula, alpha cannot be equal to half pi plus p, and k belongs to z. Please understand this. The terminal edge of the angle alpha coincides with the y-axis. The abscissa of its intersection with the unit circle is 0, the cosine value is 0, and the tangent value does not exist. The three are equivalent. If the tangent value exists, the terminal edge of the angle alpha will not coincide with the y-axis, and its cosine value must not be equal to 0. Well, we have a Pythagorean theorem related to the unit circle, which shows that the square of sine alpha plus the square of cosine alpha equals 1. Can you construct a graph in the unit circle to explain the formula that sine alpha is equal to tangent alpha then cosine alpha? We first write this formula in fraction form. Sine alpha to cosine alpha is equal to tangent alpha to 1. Can you find the corresponding line segment in the unit circle? The absolute value of sine alpha corresponds to PM, and the absolute value of cosine alpha corresponds to OM. PM and OM are the two right angles of the triangle PMO. Can you construct a right triangle whose right side is 1 and is similar to the triangle PMO? Then cross point B as the vertical line of OB to meet point C. Because triangle CBO and triangle PMO are similar, MP ratio OM is equal to BC ratio OB. Because OB is equal to 1, MP is equal to BC then OM. It is the geometric interpretation of taking absolute values on both sides of the formula. Okay, that is the main content of this lesson, the basic relationship of the same angle trigonometric function. Let's analyze the structural characteristics of these two formulas. A formula that we see from left to right is that the sum of the squares of the sine and cosine of the same angle is equal to 1. From right to left, the constant 1 can be replaced by the sum of the squares of the sine and cosine of the same angle. The square of sine alpha is the abbreviation of this formula. The square of sine alpha cannot be written in this form. The former is the square of the sine of alpha, and the latter is the sine of the square of alpha. The content of the expression is different. The second formula represents the sine of the same angle, and the quotient of the cosine is equal to the tangent of the angle. From this formula, we can get that if we know the tangent of an angle, we know the relationship between the sine and cosine of the angle. If you know the ratio of sine to cosine of this angle, it is equivalent to knowing the tangent of the angle. Since it is called the basic relation of the same angle triangle, how can we understand the same angle? In the first relation, the angle should be the same and independent of the form of the angle. For example, the square of sine 15 degrees plus the square of cosine 15 degrees equals 1. The same angle is 15 degrees. Sine to alpha is equal to tangent to alpha then cosine to alpha. Same angle value to alpha. Sine alpha plus beta squared plus cosine alpha plus beta squared equals 1, and the same angle is alpha plus beta. Second, as long as the function is meaningful, the relationship is true for any angle ... In the second formula, we should also ensure that cosine alpha is equal to 0, and tangent alpha is meaningful. That is to ensure that the alpha angle cannot be equal to half of pi plus p. That is to say, in this formula, except that the angle alpha is equal to half of pi plus p, it is true for this angle relationship. Of course, we can also make equivalent deformation of the formula for us to use in solving problems. A formula can be changed into that the square of sine alpha is equal to 1 minus the square of cosine alpha. And it can also be changed into that the square of cosine alpha is equal to 1 minus the square of sine alpha. Then perform the square root operation on both sides of the first equation. Sine alpha is equal to the square of cosine alpha minus the positive and negative root sign. The positive and negative signs cannot be taken at the same time, because it is limited by the quadrant where alpha is located, and only one of the two can be taken. For example, when the angle alpha is the fourth quadrant angle and sine alpha is negative, sine alpha can only be equal to the square of cosine alpha minus the negative root sign. Are these two formulas equivalent? As we said just now, the terminal edge of angle alpha does not coincide with the y-axis, its cosine value is not equal to 0, and the tangent value exists. In this formula, the cosine value of the tangent function must not be equal to 0, so both sides of this formula can be divided by cosine alpha at the same time, and the two formulas are equivalent. That's all for today. Goodbye.